So this is actually a really good problem because this is actually going to go into what we're going to be doing today. So it's really important that you guys need to understand what exactly they're asking. And that's exactly what Sina was at. Like, what are they asking? What do they want us to do? Well, ladies and gentlemen, when we're doing the trigonometric functions, what we're doing, like when we say like the trig, like sine of, what are we taking the sine of? What actually is that? Is it a side length? Is it a measurement? I mean, a measurement of what? What is that? What do we do the sine, cosine, and tangent of? Oh, it just went off. Huh? No, when I was doing like the sine of that, what did I do the sine of? Theta. What does theta represent? An angle, right? They're asking, when we're taking the sine, cosine, and tangent, we're taking the sine, cosine, tangent of an angle. So what they have in this case is they say, hey, I'm taking the cotangent of some angle I do not know, and that is equal to 1. Can you tell me what the angle is?
45 degrees.
That's what they're asking. However, there's more than one answer. So we have to look inside the constraint. The constraint says my angle has to be between negative pi and negative pi halves. So going back to our focus lesson, we need to know where that is. Well, if we start here, negative pi's here, negative pi's there, right? So would you guys agree with me it's in the third quadrant? That's where my triangle needs to be? Would you guys agree with me?
Sure.
OK. So I'm just going to erase the rest of this. All right. Now, we know the triangle needs to be down there. OK? And one thing that we can do, though, is kind of like immediately what Sven went to. He immediately looked at that unit circle and said, I know when the opposite over adjacent, or the adjacent over the opposite, which would be the x over the y is equal to 1, that's 45 degrees, right? Do you guys agree with me? That's the only time where you do x over y and you're going to get 1. Would you guys agree with me?
Yeah.
Yes?
Yeah.
However, does that 45 degrees, does that meet this constraint? No. So because that's the first quadrant. So let's play a little game. Zach, perfect.
Of course.
Here is a point 4, 2. OK? Caitlin, if I was going to reflect that point across the x-axis, what would that new point be? If I was going to reflect that point over the x-axis, what would my new coordinates be? Close. 4 is still the same, but the 2 is negative, right? OK, Zach, if I was going to take this point and reflect it about the y-axis, there we go. So do you guys agree with me then, if you guys were to look at this problem? We know that this point, that the point square root of 2 over 2 gives us the angle that we need, right? Right? Because that one gives us the angle we need. So you can. We know that 45 degrees, we know that the cotangent of 45 degrees is 1. Yes? We know that the cotangent of 45 degrees is 1. But that's not the point in this quadrant. What is the point? That is 45 degrees is right here. That's square root of 2 over 2 comma square root of 2 over 2. But we want to find the coordinate point down here. So by using reflections, what would that be? Good. OK, perfect. Now, if that's 45 degrees, how far do you guys think this is?
45.
Oh, I just wrote it in there, right? It's 45 degrees, right? It's a reflection. Yes?
Yeah.
You reflect this over. That's 45 degrees. Reflect it over. It's 45 degrees. Do you guys agree with me? So if they're asking you what is the angle, this angle is what we call the reference angle. That's not the angle. That's the reference. The reference angle is, remember the reference angle? Remember I said the reference angle is always positive and acute? That means the reference angle is only going to give you values of the first quadrant. This angle is not in the first quadrant because they want the angle in between this stuff, right? So if we know that the distance from the terminal side to the x-axis is 45 degrees, how big is this angle?
Big.
Right. But what?
210. Wait.
So in degrees, it's 225 degrees. I would prefer that you guys really, really, really get used to radians. If this is in force, we know this is pi over 4, right? Halfway, so this distance is pi over 4. This distance is pi over 4. This distance is pi over 4, correct? Halfway around the circle is how many force? 4. So 4 pi over 4 plus an extra pi over 4 would give you?
Pi over 4.
A full pi and 4.
So if you guys look in the back of the book, that is your answer. Yes?
I want some pi. Give me some pi.
Oh, very good. Actually, you know what? You're very correct. You're very correct. Very good. Thank you, actually, for that. Because I didn't pay attention. The angle, very good. The angle, actually, I didn't pay attention to these constraints. All the rest of the problems are like this, but I should have been more careful. The angle has to be negative, right? It has to be between this angle has to be between well,
You would have gone. Oh, never mind. Like that. Never mind.
right?
It's supposed to be negative 3 pi.
So it will be in the second part.
That would be the same angle as well. Yes, that would give you that. Okay?